So today I'm going to be solving the two-sum problem live, and I'll just do it straight off from the. I haven't solved this before, so we'll just start off by reading it. Given an array of integers, nums, and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so let's take a look at example 1. So we have an array of integers. We have a target of 9, and so we want to return indices of the two numbers such that they add up to target. Okay, so one possible solution is that you do a double for loop, right, where you check all possible combinations, and that would look something like this, right? Let's just take this as the input, right? Input, and then so that would look something like this. So we have, let's say, I equals 2, right? J equals 7, right? So you check that, and let's say that the target is 9. In this case, it's 9, but whatever it may be. But the point would be you check where I equals 2, or more correctly, since we're looking at indices, right? We'll say that I equals 0 and J equals 1, and then you check with I equals 0 and J equals 2. So that would be let's see here. That's a good way. Well, we can do it this way. Right. So that's I, or actually, let's do it this way. That's I, right? And then that's J, right? And then when you move it over, J moves over, and then J equals 3, right? So J moves over, and so let's say you don't find the combination there. Let's make the target 26 for the sake of argument, right? So when we held I at 2, or I at the value 2, index 0, and we traversed the rest of the array to look at all the combinations, we didn't find the target that we wanted, which is 26. And then we know that, so we move this here, and J always starts off 1 after I. Okay, and now we traverse again, right? I equals 1, J equals 2, which gives us 18. Doesn't work. So that gives us 1, 2. Now we're going to move J to 3. Okay, we still don't have the answer. But the problem with this is that this is time complexity of n squared, right? Because we're looping almost twice through the array. So we don't want that. Let's look at another option. The other option is let's see a little of the constraints. What are the constraints? Okay, the length of the nums, size of nums could be negative, and target could be negative, positive. Okay, great. So this will work actually. So let's solve it this way, and let's solve it this way. So that's time complexity is n squared, and auxiliary space complexity is, well, I think it's constant because I think it's constant because we are just, yeah, we're not adding anything that's relevant relative to the input of n, right? We're just adding the I and j. So that's going to be it's going to be a constant. So let's just do that, right? We'll solve that. So and we will do, so we don't even need to make a target, right? So we don't need to make some kind of a sum. So we just do a for loop, right? So for, right, let I equals 0, I less than, right, less than nums dot length, I plus plus plus, right, it's going to be double for loop, for let j equals I plus 1, and, well, it's, no, it starts off at I plus 1, so it just starts off at 1, and, yeah, it's, no, it starts off at I plus 1, correct? J is also less than nums dot length, and actually this is going to be nums dot, because we don't want it to go all the way to the end like we want j, so this is going to be nums length minus 1, and then it's going to be j plus plus, right? And we're going to check if, right, if nums I plus nums j equals to target, right? If it is equal to target, then you return, and we want to return, the output is going to be the indexes of the two numbers, correct? Correct. So we return I and j. Okay. And if, what happens if we do not, so it says only one valid answer exists, and you may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, great. So actually, we're guaranteed that there is a solution, which is interesting. Okay, but let's run it. Okay, and it's accepted. Right, and if I submit it, it's accepted. Okay, it beats about 60% speed and runtime, and beats around 60% memory, or 56% memory. Now let's do it again, because I think we can do better. Okay, and this time, well, first we're going to reset the code. Let me just go ahead and reset yes, confirm. Okay, now this is a different solution. This is going to use the sliding window solution. Is that the best way? The sliding window? Well, let's try the sliding window. So let's look at it again, right? Let's look at, right, input equals that. Let's say target equals 26 again. And we will do something a little bit different, where we still have I and j, right? So I and j. And let's see, the way the sliding window solution works I have to remind myself actually. Let's see, the way why the sliding window solution works is start off at here, right? Okay, right. There's a catch where there's a. Let me take a look actually quickly at my own notes. Right. Sliding window. Sliding window. Okay, so we have a. Let's see, the two phases of the sliding window. Let's take a look at the hunting and catch-up phase. Okay, so we have to identify. Can we use the sliding window here? I think so. Let's see. We want to identify what is the hunting phase. And what is the catching phase? Actually, it is interesting. So let me see. Am I wrong to think that this is a n squared solution? Or is it a 2n solution actually? Maybe what I did before was right. Let me see here. Let's take a look if there's some nice examples to some. Let's see what they discuss. So that's the brute force. This is what we did. It is time complexity 2n. 2-pass hash table. So 1-pass hash table. Let's see if there's a do we have a solution for 2-sum sliding window solution? Sliding window pressure fails. 2-sum. There are two versions of problem: 2-sum and 2-sum with array sorted. So yeah, the thing about the sliding window, it doesn't make sense here, the sliding window, because you use the sliding window when you're trying to minimize a window. Two-pass hash table. Let's see. 1-pass. How do we use a 1-pass hash table? Turns out we can do it in 1-pass. While we were iterating, inserting elements into the hash table, we also look back to check if current element's complement already exists. Yes. In the hash table. If it exists, we found we should return the indices immediately. So the way they do it is you may create a hash map, okay, and you loop through. You create a complement between the target and the current number. If complement is in hash map already, got it. Then you return it. This is great. Okay, so let's do it. Okay, let's do it.